Hello everyone, we'll try to solve a very good question on cubes. The question is, a cube of volume 512 cm cube is formed by smaller cubes of volume 1 cm cube. All faces of the bigger cube are painted such that an equal number of faces are painted by 3 different colors in such a way that no two opposite faces are painted by the same color. So now the cube has volume 512 cm cube. Using this we can easily find out the number of unit cubes. There will be 512. This is the volume of big cube. The volume of one small cube is 1. So there will be 512 such small cubes. And what will be the number of cubes on each side? That means in the x-axis, y-axis and z-axis. We'll just find out the cube root of 512, which is 8. So on x-axis, y-axis, z-axis, we'll have 8 cubes on each edge. So I have drawn a similar cube over here. Apart from that, we have to make sure that no two opposite faces are painted by the same color. Now we have also been given that all the faces of bigger cube are painted such that an equal number of faces are painted by 3 different colors. We know that a cube has 6 faces. We have to paint 3 colors and we have to paint equal number of faces. So 2 faces will be painted with same color, another 2 will be painted with same color, another 2 will be painted by same color. But we have to make sure that these faces having same color should not be opposite to each other. Now how to make sure that two faces are painted with same color and they are not opposite to each other? It can only happen when 2 faces having same color will be adjacent to each other. So let me assume that this front face, it is colored in red, so the face adjacent to it, it will also be colored in red. Then after that, let me assume that this bottom face is painted green. So let me assume that the face on the left side, it will be adjacent to this bottom face, it will also be green. At last, let me assume that this top face, it is painted blue, and the face which is at the back, it is adjacent to this top face and it will also be painted blue. Now the first question that we have is, what is the number of smaller cubes which do not have any color on any of the sides? Now we are talking about the cubes that will not be having any color on any of the sides. Now I hope you are already aware with the basics of cubes. We have learned that all the cubes that do not have any color on them, they lie inside the first visible layer. That means we'll remove this top layer from here. Then we'll remove this one layer from the left side, one layer from the right side, one layer from the bottom. So if we remove such a layer, that means we are removing one cube from left and right, one cube from top and bottom, one cube from front and rear. So on each edge we were having 8 cubes earlier. Now it will be decreased by 2 on each edge. So we'll have 8 minus 2 cubes along the x-axis, 8 minus 2 cubes along the y-axis, 8 minus 2 cubes along the z-axis. So that means 6 into 6 into 6, that means 216 smaller cubes will be there, which will lie inside the first visible layer and they will not be having any color painted on any of the sides. So 216 will be the correct answer to the first question. Let's try to solve the second one. What is the number of smaller cubes which are painted by exactly 3 colors? Now while learning the basics of cubes, I have told you that whenever we are talking about exactly 3 colors in a cube, you will always find that particular cube in the corners. So we'll look at the corners of this cube. We have one corner over here, 2, 3, 4, 5, 6, 7 corners, and one corner is at the back, which is at the left bottom. It is not visible. So let us try to find out which particular cube will be having 3 colors. So if I talk about this particular cube first, we know that one of its sides will be blue because that blue color will come from the top. So we'll have blue color over here. In the front face we'll be having red color, and on the left face we'll be having green color. So we can say that in this particular cube there are 3 colors involved, green, blue and red. So yes, this particular cube will be counted. So we have one such cube till now that has 3 colors on it. Let's try to find out more such cubes. Now if we talk about this particular cube, we can see that here it will be red, here it will be red, and at the top it will be blue. So this cube has just 2 colors, blue and red. So that means we won't be counting this particular cube. If we talk about this cube now, then it will be having blue color from the top, blue from the back, and red from the right. So even this has only blue and red color involved, so we won't be counting this particular cube. If we talk about this cube now, then it will be having blue color from the top, blue color from the back, and green color from the left side. So even this has just 2 colors involved, so we won't be counting this. If we come to the bottom cube over here, we'll be having green color from the left, green color from the bottom, red from the front. So this has only two colors involved, red and green. So this won't be counted. If we come to this particular cube now at the bottom, right bottom. So on the front we have red color, on the right we have red color, on the bottom we have green color. So this is also involving just two colors, green and red. So this won't be counted. If we come to this particular cube now, we'll be having red color over here, we'll be having blue color from the back, and from the bottom we'll be having green color. So this is also a cube that has three colors involved. So till now we have this particular cube and this particular cube in which three colors are involved. So we have two such cubes now. If we talk about the last cube that is remaining, which is not visible to us, then it will be at the back. It will be having the right face involved, that means the green color. It will be having the bottom involved, that means green color. And it will also have the back face involved, which is having the blue color. So on the cube that is not visible, we have just these two colors. So even that cube which is at the back, it will not be counted. So how many cubes do we have? How many smaller cubes do we have which has exactly three colors? There are only two such cubes. So the correct answer to the second question would be 2. Let's try to solve the third question now. I'll be erasing everything. So the third question is, what is the number of smaller cubes which are painted by exactly two colors? Whenever we talk about exactly two colors, we'll always go to the edges. But now while solving the previous question, we saw that there are some cubes as well which are having two colors involved. In the second question, we found that there are only two cubes which have three colors on them, and rest, that means 6 cubes on the corners were there which were having two colors on them. So that means while answering the third question, we'll also be counting those 6 corner cubes that were having only two colors on them. We'll be adding it to the final answer. But before that, we'll also be going to the edges that have two colors involved. So in total, in a cube, we have 12 edges involved. So if we talk about this particular edge, we'll be ignoring the cubes on the corners because I'm talking about the edges, only the edges, removing the corners. So on the edges, we'll be having 6 cubes, and we are able to see that on this particular edge, blue color from the top is meeting and red color from the right face is meeting. So that means all the 6 cubes on these edge, when we remove the corners, there are 6 cubes on this edge that have two colors. So I'll be writing 6 plus. Now if we talk about this particular edge, removing the corners, I can see that I have blue color at the back and blue color at the top, because this edge is formed by blue color at the back and blue color at the top. So there is just single blue color on this particular edge, so we won't be counting this edge. If we talk about this edge now, then we have blue color from the top and green color from the left, so we'll be counting these 6 cubes. So I'll be adding 6 over here. Then if we talk about this particular edge, removing the corners, then we have blue color from the top, red color from the front face, so 6 cubes on this edge also will be counted. Then if we talk about this particular edge, it won't be having two colors involved, only red will be the color used to color these cubes, so we won't be counting this particular edge. This particular edge, we have red and green colors meeting, so we'll count 6 over here. Then on this particular edge, we'll have red in the front face, green in the bottom face, so we'll count 6 from here as well. So there is one more way to do this question in a very short manner rather than counting all the cubes, checking all the edges. We can see that there are only 3 edges at which we have cubes having just one color. One such edge is over here, this one, at which only blue color is involved. Then we have this edge at which only red color is involved, and we have this edge over here which is going backwards. We are not able to see that edge. At that particular edge, all the cubes will be having green and green color, so even that edge will be ignored. So there are 3 edges on which there are cubes having just one color. So how many edges are remaining? We have total 12 edges. 9 edges will be there on which we'll have cubes having two colors involved, and we just saw that on every edge we are having 6 cubes that have two colors. So on 9 edges we'll be having 9 into 6, that means 54 cubes that will be having two colors. So we have 54 cubes from the edges. We have 6 cubes from the corner that were having only two colors. So what will be the total number of cubes having exactly two colors? we'll add 54 from the edges plus 6 from the corners, that means 60. 60 will be the correct answer to this question. So rather than checking each and every edge, you can directly go this way as well. Now the fourth question is, what is the number of smaller cubes which are painted by exactly one color? Now while we were going through the cube, we were able to see that there were 3 edges on which there were 6 cubes each on every edge that were having only one color. So that means 3 into 6, 18 cubes will be coming from here, from the edges. And when we talk about exactly one color, first of all, we always go to the face cubes. That means cubes that are present on the faces, excluding the edges and the corners. And we count only this particular part because we have removed the edges and the corner in this particular part. So this will be a 6 cross 6 cube. In total we'll be having 36 smaller cubes on this face. So on every such face, we have 6 faces on a cube, we'll be having 36 cubes which will be having only one color. So 18 cubes came from the edges. We saw it while we were going through the edges. We were able to see that there were some cubes which are having only one color. Though 2 faces were painted with the same color, but they were having only one color. So 18 came from the edges. We have 6 faces. On each face we have 36 cubes that have just one color. So total 216 cubes come from the faces. So if I find out the total number of cubes that have exactly one color, so 18 plus 216, it gives me 234. 234 will be the correct answer to the last question. So all the questions on the cubes, they should be solved very properly. Even a very small mistake while you are visualizing the cube, it could lead to a wrong answer. So I hope the explanation was clear to you. If there's a doubt, please ask again. Thank you.